Question 9. An aircraft flies from P latitude 12 degrees north and longitude 11 degrees west to Q latitude 12 degrees north and longitude 11 degrees east in 2 hours, and then changes its course and arrive at S latitude 44 degrees north and longitude 11 degrees east in 6 hours after leaving Q. Full stop. Calculate correct to 3SF. A part of the question: total distance covered. B, average speed of the aircraft. C, time difference between Q and S. Use pi to be 3.142 and radius of the earth as 6,400 kilometers. I want to show the point on the earth, so you draw the earth as a sphere. To locate the various points, you start by drawing the principal axis, that is north south, and east west. After that, you draw the two reference points, that is the equator latitude 0 degrees and the prime meridian longitude 0 degrees. Now, the first point is north of the equator. So the first small circle you draw here is a parallel of latitude. So this is latitude 12 degrees north. Now the longitude is on the west side, so you draw this as longitude 11 degrees west. If you move to point Q, the same latitude as this, but the longitude is to the east. Already this longitude is 0 degrees. You draw the one for 11 degrees east. You move to point S. Point S is latitude 40 degrees north, that is after 12. So somewhere here you have latitude 44 degrees north, the same latitude 11 degrees east. So this is how the diagram should look like. All that I illustrated earlier is what you have here. So this point is latitude 12 degrees, longitude 11 degrees, that is P. This point is latitude 12 degrees, longitude 11 degrees, that is Q, and this is point S. So we are asked to find the total distance, that is from P to Q and Q to S. The solution continues. Since distance along small circle is not specified by default, we are to use the formula for calculating distance along great circle. Such distance is this: total distance is equal to distance PQ plus distance QS. Distance PQ is on the same latitude but different meridian, and as such angular difference becomes 11 degrees plus 11 degrees, and that is 22 degrees. Since the points are on different longitude or different side of the meridian, you have to add them to get the angular difference. So distance PQ is equal to 22 degrees over 360 degrees times 2 times pi times radius of the earth. This simplifies to this. When you divide, you have 2457.7422 kilometers. Distance QS is on the same side of the meridian, and as such, the angular difference is through subtraction. The angular difference is through subtraction. Since point Q and S are on the same side of the meridian, you have to look to the latitude to get the angular difference. They are on the same side of the equator, so you have to subtract the two angles to get the angular difference to be 32 degrees. Distance QS is therefore 32 degrees over 360 degrees times 2 times pi times radius of the earth. That simplifies to this, and you have 3574.8978 kilometers. Total distance becomes the addition of the two distances, and that gives this. To 3SF, you have 6030 kilometers as the total distance. Roman figure 2, average speed, that is total distance over total time. The time for the whole journey is 2 hours for the first journey plus 6 hours for the second journey. That is 8 hours. So you have total distance over 8 hours, and that is 754.08. To 3SF, you have 754 kilometers per hour. Roman figure 3, time difference between Q and S. The time difference is simply 6 minus 2, and that is 4 hours.